Alright, so let's start talking about it. We gotta be able to, I need y'all to hear me on this. I know this is day 2, so it's not been a ton of time with this. But this is one problem that we've spent 7 minutes on since that bell rang. We gotta get it moving a little bit faster. So here's something I want to point out, and this is important. A bunch of us are just trying to kind of memorize these rules, which the rules are good, like they are helpful. But I want you to think about something that, especially when it comes to the end behavior. What do you know about this function from the beginning before we start trying to figure these things out? These are the end goal. What's the beginning piece to notice? The what?
It's negative.
What the heck is it? What's the -3 though? Oh, the leading coefficient. Guys, you can't just say it, because is the leading coefficient the only thing that matters? No, that's actually it's important, but it's the lesser of the two things. What's more important than the leading coefficient? Yeah, I'll agree. My leading coefficient, oh, the degree, not degrees, degree. Degree is only one thing. Leading coefficient is -3, so focusing on the fact that it's negative. What's the symbol? Does anyone remember the symbol we use to indicate degree? N, right? So the degree is what again? 5. Okay. So I need us to think about this and talk about this. I want you to picture in your brain, what would a degree of 5... Hey, Deshaun. Up here. Okay. What would a degree of 5 tell us about that function? Like if I was trying to graph it, what do you know about that function right away? Say again. Hold on to the idea, not what I was thinking about yet. Let me ask this, what does it tell us about the end behavior? Hold on to that. What does it tell us about the end behavior? It's got to be different, right? Now, I want you to think about it. When we talk about the ends, there's only 4 possible ends. They could either both go up, they could both go down, they could be different where one is, on the left side it is down and the other one is up, and on this side it could be start up and end down. Okay, so those are the only 4 end behaviors. Notice, I will point this out, like if you picture this or you draw out this picture, that might help you with the end behavior. Stop trying to memorize stuff. Draw it out, picture it, graph it. Okay, so here's an important question. So which of this is it? We said it's different, so it's got to be one of the bottoms, right? Which of the bottoms?
Right.
Why is it the right one?
Because it's starting positive and negative.
How do you know that?
Because the note I wrote yesterday.
Because the note you wrote yesterday, what's that note fully say? Give me more information. Yeah, we might want to use this information today, guys. Does anyone know why it's negative? Like, does anyone remember what I connected it to yesterday to tell us it's going to be, say again?
Linear coefficient.
The leading coefficient, there's something else though.
Linear.
Linear, right? If this was linear and there was a negative slope, what's it got to do? It's got to go down. It's got to, what's that more mathematical term to go down?
Decrease.
It's got to decrease, right? Overall, it's got to decrease. And it might change what's happening in the middle, but overall, it's got to go down, right? Woo! It's got to go down. All right? Needs to see that. We good with that information. Now, having pictured this, right here, having pictured this, now I can do my end behavior. And I feel like, bless you, I feel like this is one of those things that some of us are missing. It's hard to do end behavior just memorizing it. You sketch something like that though, it might be easier. Another hint that I might give you, and I might put this on my Frere model on the section that says end behavior. How many ends do we have? 2. There's one that is on the left and one that is on the right. So if I'm doing end behavior, I'm going to put LHS and RHS. Any guesses what I mean by LHS or RHS? Left and right, so left-hand side and right-hand side. That's it. That helps me focus my attention. Left-hand side, I'm over here. Don't forget, there's always 2 parts. It's as x goes towards something. Remember, you do your independent variable first. You want to have that as in there. So on the left-hand side, what is x going towards?
Positive. Well, X would be negative.
I would say on this side is my negative side, right? So it's going towards negative infinity. And as x goes to negative infinity, y is approaching infinity. Okay? So please understand, when I ask you what is the end behavior, don't just tell me the end behavior is different. Yes, that is the beginning point. That tells us it's one of these, sure. But I want the actual end behavior. I don't know exactly what this function looks like, but I know it has to have that end behavior. And on the right-hand side, what's happening on the right-hand side?
It's positive X infinity.
So x is,
Positive infinity.
it is not positive infinity, it is going towards, right? You saying it is positive infinity means that x is equal to infinity. Can we get to infinity?
No.
No, I know Buzz Lightyear was all about to infinity and beyond, but you can't do it, right? Like infinity, you can't get there, okay? So we can only approach it. So x is approaching infinity. As x goes towards infinity, what's y doing?
Going negative towards the
So it's decreasing, going
negative.
down to
Negative.
negative infinity. Be careful, it's negative infinity, right? So we need to recognize this, right? Like that's our end behavior, right? That's what I'm asking when I ask for end behavior. Don't forget that detail. So y'all saw those foundational pieces yesterday. Should have written those notes down, Mason, so that we can refer back to them later. Now, this next piece, I need you to see this. How many x-intercepts could this function have?
3 and 4.
It could have 5. It could have 3. Or it could have 1, but I think you're mixing something up there. I'll point this out. I want you to think about this. If, which I wish I knew where my large ruler was, my yardstick, but I want you to think about this. Oh, there it is. Why did someone put it over here? I'm going to let this become my x-axis. All right? If this is my x-axis, I'm going to make this more exaggerated in here. Okay. How many x-intercepts do I currently have?
3.
1, 2, 3, 4, 5. And what was the maximum number of x-intercepts we said? 5, okay. Now let's say that I shift this down a little bit. How many x-intercepts do I now have?
3.
That's going to be 4. One is a 1 here, this is double root. 2, 3, 4. So is the next number of x-intercepts 3? It is 4. Let's see if I can get it so it's only 2. Or only 3. Can I get only 3? Yeah, it's tough, but I can do it on this one. Can I do it so it's only 2? Yeah? Up there? Can I get it so it's only 1?
Yes.
Yeah? Can I get it so that it's 0?
No.
Why not?
Because it will always be going one way.
So remember, what's the minimum y value? Not minimum is negative infinity. The maximum is positive infinity. You know what number has to be between the negatives and the positives?
All of them.
What number? 0. Why is that important? Because our x-intercepts are zeros. Remember, the x-intercept have to have an output of 0. So an odd degree like this has to have at least one x-intercept. Notice it's not just 5. Remember we said it's 5 or less. Some of y'all were doing 5, 3, 1 going in pairs, right? But what are you actually thinking about when we think about pairs? Huh? Extrema came in pairs. What's the maximum number of extrema possible here?
4.
or it could be, so extrema are what come in pairs. I need you to be careful about that. X-intercepts come in ones because you can have a double root which just, that was terrible. You can have a double root which just reduces your number of x-intercepts by 1. What could reduce your number of x-intercepts by 2? So if I draw this, right, I only have 1, 2, 3 x-intercepts, but how many zeros does this function have to have? What degree is this? 5. So how many zeros does it have to have? How many roots? Has to have 5. So what are the other 2 zeros? Remember, if we can't see them, they're imaginary. So you got to pay attention to the multiplicity of the zeros. So one of the things I'm going to be asking is for you to not just identify from the equation how many zeros a function has. I'm also going to ask you, okay, you know, here's the equation, here's the graph. How many real zeros does it have and how many imaginary zeros does it have? Like, that's something that I'm going to ask you to identify. And so you have to recognize, hey, it's 5th degree, so it has to have how many zeros? 5, but I only see 3 real ones, so the other 2 have to be imaginary. Like, those are questions I'm going to ask built off of what we have studied in the past. All right, so let's get some more practice and ideas in. So we're going to continue, that's frozen, you can't see that. We're going to continue with this mathematic activity. And in this mathematic activity, there are some check your understanding questions in it. So not the Frere model questions, but questions on the back of mathematic. That's going to help us continue practicing this. And then we're going to go into the textbooks that we have for this class. And so you'll tear some pages out of the textbook and we'll use those. Okay, so remember, you filled out all this yesterday. We did that gallery walk to find this pattern. This isn't just Mr. Kinney lecturing us on the end behavior. I'm trying to bring back out what we looked at and discovered yesterday, because math at the end of the day is the study of patterns and relationships. We discovered a pattern of relationship. Now we got to practice with it. We got to master it. We did the notes yesterday on all this, right? So we got our x-intercepts and roots, connecting standard form equations and graphs. We did end behavior, and we did the possible number of extrema, which is what we just practiced. So on the back of your mathematic activity, the higher powers one, I'm going to do one of these with you, okay? And what I need you to do is this. I want you to try to create a polynomial equation in standard form that has the following characteristics. So notice what we did yesterday is we had an equation and we found the characteristics. Today I'm giving you the characteristics and you got to come up with an equation. And it's getting a little bit harder each time. It's progressing you to developing your understanding. So here's the thing. When I look at this, when I'm looking at number 1, it tells me it has 4 x-intercepts. Is that possible? Because notice it does say, if it's impossible to explain why. Is it possible to have 4 x-intercepts and the same end behavior? What would be a case where that's true? Well, not just that. Well, it's what?
It's even.
Even what?
Degree.
Even degree, right? Like, so we can have some double roots in there, which is why it could be, be careful, because like, here's the thing. If I make this equation, I'm making something up, by the way. You don't have to have an exact equation that works. But if I make this up, is it possible that this has 4 x-intercepts? Yeah. It has to have how many zeros? 5, but it could have a double root, right? Would this equation, though, be able to have the same end behavior? It's an odd degree. What do we know about the end behavior for an odd degree? It has to be different. The end behavior for, go ahead and join the jacks for me. I got the space open. The end behavior for an odd degree has to be different. So is that equation possible? No. Okay. So now I need to think about this. So what kind of What do I know about my function from the very beginning? So it's got to have at least 4 x-intercepts, and the end behavior has to be the same. So what's the lowest degree it could be? It could be 4th degree, or if it's 2nd degree, what's the most number of x-intercepts it could have? The most it could have is 2, right? So it could be 4th degree or, but if it's 3rd degree, then it would only have how many x-intercepts? It doesn't have 4, does it? So it's 4th degree or what?
0, 1.
Let me just ask a question. Could a 5th degree have 4 x-intercepts? Could a 6th degree have 4 x-intercepts?
Yeah.
Could a 7th degree?
Yeah.
So if it tells me it has 4 x-intercepts, it has to be what degree? 4th or higher. If it's lower, we can't have 4 x-intercepts, right?
Yeah.
But it also tells me the end behavior has to be the same. Okay, so I'm going to give you 2 options. Notice I'm just making something up. It's not guaranteed. Okay? Which of those 2 polynomials could satisfy all of those requirements right there? This one right here? Why this one? So the degree is 6.
And you can have 2 imaginary numbers.
So hold on, keep going with that. I love that reasoning, right? So if it has not 2 imaginary numbers, 2 imaginary well, they can't be imaginary x-intercepts, they can be imaginary roots. So they could be imaginary roots or zeros, right? So they are numbers, but it's the root that we're talking about there. So 2 imaginary roots, which would leave me with 4 x-intercepts. But I mean, this could just have 4 x-intercepts, right? Would they both have the same end behavior? How do we know they're going to have the same end behavior, Mason? They're even degree, right? Now, don't just say they're even. There's actually something called an even versus an odd function, and that's not what we're talking about right now. We're talking about the degree. Yeah, neither of these would be even or odd. Functions, they're even degree. So they're even degree, so they would have the same end behavior, right? So why are y'all picking this one instead of this one? Or could it be either? Say it loud, Roger.
It really can just be either.
I want to push back on that. It can only be one of them. I'm glad you're thinking that, but I will say it can only be one of them. I'm asking which of these 2 could be the function that has these characteristics. This one? Okay. Let me ask you this. What does this last characteristic tell us?
I know which, yeah. It has to be positive.
Why does it have to be the bottom one?
It goes, x is negative infinity, so it has to
So
be.
as x goes to negative infinity,
It has to go negative.
y is going
To positive.
to positive infinity, so it's going up, and if the end behavior is the same, it's got to look like this. So which of those 2 could it be?
True,
The
it's true.
second one. Why does it have to be this one?
Because it has to be a root.
Has to have a what?
It's going, it decrease.
Say again.
It has to decrease.
It's not that it has to decrease. Why does it have to be this one? We focused very heavily on the degree so far. What have we not talked about? The leading coefficient. It's because it's positive, so it's got to go up. If the leading coefficient is negative and it's even, they're both going to go down. Because what's the leading coefficient here? So it'd have to be going down, but on this characteristic, it has to be going up. So you have to think through all these different things. Now I want you to notice, this entire conversation, have we talked about this at all?
No.
Does that matter to satisfy these characteristics. So if I change this to a minus and this to a minus, would that still work? Is it still even degree? Could it have 4x intercepts? Could it be going up? So could this still work even though I changed these ending? I want you to think about that. Guys, there's infinitely many correct answers to these. There's not just one. There's infinitely many. And heck, if I change this -3 to a +3, does this one now work? So, is there one right answer here? No, there's lots and lots and lots of right answers. You just have to come up with a standard form equation that satisfies those characteristics. That's it. So, talk with each other, think it out, discuss it, and I just want to see some possible equations. So, I want communication, I want collaboration, I want y'all thinking, and so let's get up to our vertical surfaces and let's work on 2 through 6. I'll bring us back periodically. The one thing I will ask is, do not write on the white books because we did not quite finish everything yesterday in 4th block, so I want those graphs still up, or in 3rd block, so I want those graphs still up there. So if you're on the chalkboard wall, write on the chalkboard wall. If you're up here, you can write next to the white book. You all can write next to the white book. You can erase the features. I just need y'all to leave the graphs there. Does that make sense? Okay, let's go. Numbers 2 through 6. Let's get as far as we can. Think about all those different features. Come up with something. Literally, you just have to come up with something.
Okay, number 2. 5 zeros for negative.
Should not throw erase.
Don't erase the white book, just write on the chalkboard wall.
Wait, does it matter? Like,
It just has to satisfy those characteristics.
so it doesn't matter what number.
It just has to satisfy those characteristics. So try to find, you can think of something, so you think about what those different features tell you. So if it has to have 5 zeros, what does that tell you?
Has to have 5 zeros.
No, there's something else about the equation that it has to tell you. What does that tell you about the equation? Remember, what has been the focus of this entire lesson? The degree and the leading coefficient, that's it. Great, so if it has 5 zeros, what does that tell us? Just the degree is 5. Highest power. Yes. Okay, so the degree has to be 5. Okay. Couldn't that work with 4 terms? Okay. Now, we gotta look at that last piece, the end behavior. Okay.
4 times negative x.
Which one? That's the name
Crossing out here. On both sides. Well, it's the same, they don't say the same direction, so we need to go back.
Yeah.
So if I use negative 3x,
No, one more time.
if I use negative 3x to the fifth plus 4x to the third plus 8x.
One thing I do want to encourage you is remember, we need this to be a function, not just an expression. And then let's think through this. Let's think through what we see. So we see 5 zeros for sure. So we know the end behavior is going to be different, okay? Because the end behavior is going to be different, and that's negative, is it going to be here and here, or is it going to be here and here? Okay, y'all agree?
So X,
This one right
we're
here.
gonna go that way, so that's why it's
We agree?
and the Y.
Okay, so I want you to think about this. If this was a line, what kind of slope would that be? What kind of slope would that be? Jumping over here, it's gonna have to put a space for you to work, and then you'll just have to sit right here. So then you'll have to sit with the fours, or the fours, which we don't have. Space for it. That'd be a positive slope, right? Isn't that a positive slope that's increasing? What's your leading coefficient? So that.
They have to be the
same,
same.
so
This is
Good, different, yeah.
So look,
Okay.
that's
Now,
what we.
I want you to compare this to this in here. Does that match?
For innocence, but
be.
that's.
So as x goes to negative infinity, that's saying y is going, so it's going, so does that match? Okay. Yeah, but notice we don't have that detail, but does that match all three of those equations? Okay.
Y'all on two?
There's other options, but yeah, that works. What's up? So why do you think that?
Yeah.
Okay.
But still. X.
Well, yeah, because it don't say you gotta be the same direction, so. Yeah, that
It's
would.
going left.
Hold on 1 second, so I gotta-
I guess it has to be the same.
Alright, so, okay. So number 2, 6x. So I want you to remember, so what does this tell us about the end behavior? This tells us about the end behavior. It's gotta be different, right? So there's two different options. So I'm gonna make this my x and this is gonna be my y. So
Or
it's gonna
X.
be either,
Or X.
so it's different, so if this is going down, that's going up, or
Three zeros and three times. And three times.
it's going up here and down here. So if that's positive, which of those two would it have to be? This top one up here? Okay, so notice this, as x goes to negative infinity, y is going
Three.
14.
to this one? That's going down, isn't it? If it's going down, what kind of numbers are down? Right,
Five.
so that's not going to positive infinity, that's going to,
And behavior is different.
but what does that say over there? Y needs to go towards what?
Negative.
So which one does it need to
Y.
be? It needs to be this,
Okay.
That means it looks
it could be
like-
anything after that. Now, I want to caution you and remind you, this needs to be a function, that's not a function yet.
That'll be just.
There's something really important you're missing to make it a function. Okay. I'm gonna grab these chalk real quick. Should I grab one?
Six,
Like
six,
4 to
finish,
the power of
So they could, yeah.
3 or something, and then plus 8.
Can you circle it with the ball?
I'm circling because I want you to review those.
Yeah, and then.
One thing I do want to remind you is, so I want you to review those. I haven't checked the last one yet, but I want you to review this. I do want you to remember, there are some of these that are impossible.
And then right,
So,
yeah,
Three would be the last one.
is that a function?
What is a function? It has to have what? Each,
Like each of the values,
which values?
the X, Y.
So each of the inputs maps to not just n, but one and only one output. So if you don't have outputs, it's not a function. You now have
And also
outputs,
because
so it's a
the
function.
3, 7,
Okay, just keep it going.
It has to be.
There's been some phenomenal communication, I'm loving it. So let's bring it up here, I'm gonna give you some time to write some notes to your future forgetful selves, Mason, because we are future forgetful selves, and I wanna make sure you get some notes today. The notes that you can study from, the things that I write on the board. What do you mean, what kind of notes? Have we never learned how to be a student? Whoa, 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 whoa. Did Ms. Kowalski ever let y'all sit down? Did I? Well, no, we stand in, we engaging, come on, up here, let's go. I did not before, and for the most part, I remember Ms. Kowalski getting on to y'all saying, what are y'all doing? Get
Well,
up
because
here.
we were sitting down in the back.
Go quickly. Yeah, well, I don't want you sitting in the back or sitting in the front, I want you standing up here. Okay, so, I want us to go through these things. What did I just say? Thank you, Kayla. Guys, I need y'all to recognize, I need you to think about this. This isn't for kicks and giggles. If you are standing, that is making your blood flow more and it forces you to be more engaged. It's not that I'm just doing this to be a jerk, it's because it helps. When we sit down, it is easier to fall asleep. There's a couple of us in here that we know that to be accurate. Alright, so I just want to talk through a couple of these and I want us to recognize some details. I will put questions like this on your test, 100%. Like your demonstrating understandings, your test, I will give you stuff like this. But we need to recognize and keep in mind, like 5 zeros, nobody in here did anything other than a 5th degree here. Could this function have been something like x to the 7th plus 4x squared plus 9?
Yeah.
Yeah. Because if you did that, that means it will have 5 zeros, but 2 of them will be imaginary roots.
Be careful, I need you to think about it, and be attentive to this. Zeros and roots are the same. X-intercepts are what are slightly different.
Two imaginary x-intercepts. So,
One, you can't have imaginary
It'll
x-intercepts.
probably be double. Well, I always say probably double.
So, let me point this out. How many roots does this have?
7.
So how many zeros does this have?
7. Well, no, it can have 5 zeros with 7.
I don't know.
Wait.
This could have 5 x-intercepts
It can have.
and 2 imaginary roots or zeros, but my point is, and so I'm glad I asked this question, my point is this is impossible. If it said 5x intercepts, yes, it could be 7th degree. But by it saying 5 zeros, it has to be what degree? It has to be 5. So we have to keep in mind the difference between x-intercepts and zeros. Zeros are almost synonymous with roots. So in here has to be 5. If they're imaginary roots, they are imaginary zeros, can't have that. We can't have 5 real and 2 imaginary. That would be 7. We can only have 5. So this had to be 5th degree. There was no other option. Would that give us 4 terms?
Yeah.
Or at least it's possible, right? And then we needed to recognize, and so notice if you try just writing an equation or just doing the end behavior without a graphic, it's hard. But if you draw out a little sketch and notice, hey, this is just saying go to the, what direction is that telling us? To the left. And this is telling us to go up, then I can see my end behavior clearly. It's got to be different in behavior, and it has to be that to satisfy this detail. So, as long as you had a negative leading coefficient and 5th degree, you're good. That's what all of this tells us. Just had to have negative leading coefficient and 5th degree. As long as you had those details, your equation worked. That's why you can get lots of different possible options. Now, 3 was the first one a lot of us freaked out on. Deshaun literally looked at me and goes, Mr. Kinney, that's impossible. And I said, yeah. I didn't say yeah, I said, yeah, look at your directions. And he goes, oh, yeah, read your directions all the way, guys. That's one of the things that's biting us in the butt on some assessments, is we don't just read the entire directions. Read all your directions. All right, so 7th degree, but the end behavior has to be the same. That was contradictory information. And you have to clearly communicate how it's contradictory. 7th degree tells us n is equal to 7, which is odd. in behavior is the same tells us degree is, well, I should say odd degree. Make sure you use clear language. Degree is even. Can that happen at the same time? Yeah, that's impossible. Can't have an odd and even degree at the same time. Alright, notice I'm clearly communicating that. Down here, there was actually a lot. Like, if you looked around the room and you talked to multiple groups like I did, you realize there's actually not just one way that number 4 is impossible, there's multiple ways that 4 is impossible. First off, if it's 3 zeros, not 3x-intercepts, 3 zeros here, the degree has to be 3. So odd degree again, but if the end behavior again is the same, the degree has to be even. That's impossible.
You can't have 3 zeros and 3 terms.
You also cannot have 3 zeros and 3 terms, right?
The maximum of the terms would be 2.
The max here is 2.
0, 2. I mean 0.
So it could be 2, but could also be
0.
0. Why 0? Why is it also possible that it was 0 here? Remember, those terms always come in pairs. The terms have to come in pairs, so 2 or 0 there. Does anyone know what the degree would have to be in order to have 3 terms?
4.
So n could be 4, or, yeah, there you go, 6, or 8. Notice, to have an odd number of terms, it has to be even degree, right? So these are all things that are showing contradiction. Any one of these would have been acceptable. Alright, so I want to focus on this number 5 here, and this will end for now. There was debate about this one where some people were like, oh, that's impossible at first. But notice how I changed it. This says 6 what? X-intercepts. I'm going to come back to that in a second. In behavior being different tells us what?
It's going to be negative. Well, no. The degree will be odd.
N is odd, right? That tells us the degree has to be odd. Is it possible to have an odd degree and 6 x-intercepts? Yes. If it's 7th degree, it just means I have a double root. Notice it's not imaginary there. Have you noticed, I don't think I've mentioned this yet, imaginary roots have to come in pairs. Because the only way you get an imaginary root is if you're taking the square root. And when we take a square root, what do we always get? A positive and a... So, imaginary roots do always have to come in pairs. So it can't be 7th degree with 6 x-intercepts and 1 imaginary root. It would have to be a double root somewhere in there. You don't have to memorize that, but that's something to notice. So notice 7th degree here. So this means n is 7 or what? Higher, right? If it was less, right, we would not be able to have 6 x-intercepts. So n has to be odd here. N is 7 or higher here. And then what does this tell us? So going left and up. Now, I need y'all to pay attention to this because I think everyone answered this the same way. Does that mean that it, oh yeah, and then it has to be different. Okay, never mind. So it has to be different. So up, left and up, and right and down. So the leading coefficient has to be negative. Remember the degree would have to be odd. As long as n is odd, the degree is 7 or higher, so 7, 9, 11, etc., and the leading coefficient is negative, you're good to go. I will point out, notice, and I hope you're noticing this, if you annotate what this tells you about the equation, does that make it a little bit easier to write that equation? That's what I would do. Like, that tells me right away n has to be odd. That tells me right away n is 7 or higher. And then leading coefficient has to be negative. Notice I drew my little sketch here to help me visually see it. All of these things can help you figure out what's going on. Okay? So let's go back to our groups. Let's write down some notes on this sheet. And maybe if we didn't write a ton on our fair model before, that we add in some details that we need. I'm going to leave the camera rolling for just a minute so that anyone who needs that can see it. Because I think Jaden was standing in the way for a little bit, which is fine. You're good. Okay, but that way you can see it. Is that what you were laughing about, Tyler? Yeah, I saw Tyler laughing.
So he was standing away on what you were doing for it, and then moving while you were doing it.
Okay.
That's all.
That's not what I heard. So remember, guys, I annotate, I write in purple so that you can clearly see what I am adding on to it. You take advantage of that so that you know what you need to write. Think about what we discussed so that you can add in those extra details. Because remember, is there only one? Alright, I'm going to erase the board. Hopefully you got all the notes that you need to at this point. What I will say is we're going to look at the next part of this check your understanding, and then we're going to get the stuff from the textbook. So what I want you to do is, this shouldn't take too long, I want you to work with your small group. You can stay at your desk and I'll come by and see what you're writing. But I want you to answer those questions that, I think they're all true false questions, aren't they? Yeah, so just a couple minutes. Now, don't just put true or false, just like on an assessment for me, you need to justify it. Just try it on your own. If you want to go talk to a group in a minute, you can. So talk with each other, come up with your answers, and justify it. Tyler, it helps when you actually are focused on the task at hand here. Yep, thank you. So that bottom section where there's that graph given, work with your group on identifying if those statements are true or false.
End up with the group. Explain why, because the end behavior is different. So the degree has to be odd.
Okay. Is there any other reason you know it's true? Because I see one more. You don't see it? That's fine. Move on to the next question. I'll talk about it then. 'Cause I don't see anyone else getting it either.
In behavior is different.
So what do we think of number one? True because what? Behavior's different? Okay. Does anyone see another reason that might be true? Say again.
You said it's odd.
Now, is it possible to have 5x intercepts and an even degree?
Has to be odd.
It's possible,
For it to be
right?
different.
Now, I don't see any double roots or anything like that, but I do just want to point out it's possible, right? There's another reason why I know it has to be odd. If you don't see it, move on to the next question and we'll talk about it. Because again, I'm not seeing anyone else notice it yet, but I just wanted to ask that question.
The degree.
Hey, by the way, what do y'all think A means in number 2?
A is greater than 0.
No, what does just A mean?
A means
Concave.
So would it be the concavity, but it's kind of
It is
connected?
the leading
the code.
Yeah, look at that function. Doesn't it say AX to the n? So the A there is your leading coefficient. A for the leading coefficient is very common, just like we did see with parabolas.
Graph.
What are we thinking? Not sure about 2? What is number 2 saying?
True or false? A is greater than 0.
Yeah, but what does that actually mean?
A.
But what is A? We just talked about it in the class. Notice A is right here in that equation. So what is A?
They're greater.
It's, I mean, it could be.
Not greater coefficient, that's not a term we use.
The LC thing.
Yeah, what does that L stand for?
There's no number that would be 1 on that.
It's kind of in the front, kind of like a
Yeah,
line.
you're right. So it's false.
This is the front of a line, the line. So it's a leading coefficient, right? Okay. So the leading coefficient is greater than 0. But what does that mean if it has to be greater than 0? What's greater than 0? What type of numbers? Oh, I'm telling you there that the leading coefficient is positive. Is that a true or false statement?
So
So why do we think number 2 is true?
Well, I mean, how many can have a coefficient?
I would agree, but what does a greater than 0 mean for a?
That the coefficient has to be.
It has to be larger.
Yeah, but what kind of numbers are bigger than 0? Oh, the what? That's saying the leading coefficient is what? Okay, still think it's true?
Yes.
Okay, explain why.
Okay, true.
Look at your graph.
Because that is not, wait, hold on. That is not, wait, I'm so confused now. It is not a polynomial.
That is
It's
at the
false.
end, it's a constant with no
It's false.
information given?
It's false.
But you see it, the one
It's false.
Ah, there's some good thinking.
Because
So why is number 2 false?
it's going left, like it's going negative and up, like that graph over there.
So you're looking at that end behavior. I will point this out, this might help in the future. I want you to think about this one. This is what I always look at. If I connect those end behaviors, what kind of slope does that line have? A negative, so what kind of leading coefficient does this have? Ah. But this is saying what the leading coefficient is
Or
greater than 0.
What are you reading?
So, whenever, and I talked about this before, whenever I think about an even degree, what's the most basic even degree we have studied?
you don't know what I'm saying?
What's the most basic even degree function we have
The
studied?
degree on this
Okay, so if it's linear, that's y equals mx plus b,
I'm
right?
talking about the coefficient.
What's the
coefficient.
degree of that? That's
Leading
one, is
coefficient
that
is
even?
negative, it's going
So it's not the most
left.
basic even degree, that
It's
might be
going
the most
negative
basic,
X and up.
what type of degree?
Y.
Odd degree, notice that's why I broke it back down to that linear here. What's
But if you look
Ah,
at
the
other ones,
quadratic.
coefficient.
So if I'm thinking about an even degree,
Yeah, I know. But
I'm
like-
thinking about a parabola for the end behavior. If I'm thinking about the odd degree, I'm thinking about a line for the end behavior. Notice not necessarily what's in the middle, because the middle will be very different for each of them, but the end behavior for all even degrees will be the same. The end behavior for every linear, or for every odd degree, will be like a linear that has different.
Do it every-
Right. Okay.
Like right X.
Alright, keep looking.
And then arrow, and then put negative there. And then do Y.
Okay, so what are y'all thinking about for 3 and 4?
Positive.
True because C is positive, how do you know C is positive? What if it's adding a negative? I mean, but it could be, right? You need to base it on the graph.
Well, okay. C is the y-intercept, right?
Is that what it's telling you based on that equation?
Because the Y.
It was for the standard form of a quadratic, but we don't know this is quadratic, we just know that this is a polynomial, right? But look, do you remember why the C was the y-intercept in a quadratic? Okay, so what do we know about every y-intercept that's ever existed? So what happens if I substitute 0 in for x there, what does that become? Here? Or my left one? So if everything has an x, and I substitute 0, everything with an x becomes what? 0, and what am I left with? C. So is that C my y-intercept?
Because I originally had true.
That's what I want you to think about.
3 could be 7 and 5
Positive graph.
So here's the 0.
Alright, let's bring it back together, let's talk about it. Number 1, n must be odd is what type of statement? True. Okay, so we're all in agreement it's true. And we all came up with the same reasoning here, but I'm going to push on it and add something else. Everybody said the same thing, that the end behavior is different. That's why we know it's true.
You could also do because it's 5, about 5 zeros.
Well, it has 5 x intercepts. Now, it's not guaranteed that it has 5 zeros.
I'll say because it has 4 terms.
That's better reasoning. My point is, because it's not, I will say this, it does not look Well, there's definitely no multiplicity of 2. How do I know there's no multiplicity of 2?
Because there's no double.
There's no double roots. We know that because none of those are bouncing, right? Now, it's unlikely, but it is possible, but it usually curves through, so it wouldn't be the case. But if it came through here like this, see how it slightly turned through there?
Yeah,
So what kind of root would that be?
that'd be a triple root.
That'd be a triple root, right? And then if it did the same thing here, let's see, so that would be 3, then 6, 7, 8, 9, no, so it's still gonna be odd there. So more than likely, yeah, I would say right, but I would point this out. How many extrema does it have?
4.
4, okay? And the way we get the number of extrema is the degree minus 1. So to get a 4, the degree has to be 5. That would just be the max, or it could be 7, or it could be 9. So remember how they come in pairs?
Yeah.
But it has to be odd. That's what I would point out here is, remember, if it's even number of extrema, n is odd. So it's just a few different things there to keep in mind. Okay? All right, true or false? What is A again? That's my leading coefficient. Okay? The leading coefficient has to be greater than 0. And Deshaun was confident early on that that was a true statement, but you switched that. You started to say what again?
That is false.
Why do you know it's false?
Because it can't go up and to the left if it's a positive.
So in behavior, or the degree is odd for sure, right? And so the the in behavior has to be different. And this is something I want you to understand or notice here. This is something that I always do, is I always connect my in behaviors. At least with an odd degree. Like that. Notice that creates what shape? A linear, right? Is that decreasing or increasing?
I haven't done that today.
That's decreasing. And if it was a decreasing line, the slope is, what is the slope here? Negative. And what would that slope also be for a linear function based on what we've been discussing here? It is also the leading coefficient, right? There's not a whole lot going on with a line, but that slope is my leading coefficient for a line. So I talked about this with Jaden's group. What is the degree for y equals mx plus b? The degree is 1. This is the most basic odd degree there is. It's the most basic odd degree. So whenever I have an odd degree, I think back to that for the in behavior. Because the middle may be very different, but the in behavior has to be the same. Okay, so the linear tells me a lot about this in behavior. So the leading coefficient is positive, is false. Right? That leading coefficient has to be negative. I connect it and I see it that way, okay?
Locked it in, bro.
Yeah, we're getting there. Questions about number 2 before we continue? Samaja, you good? Making sense? You just bored? That's why you zoning out on me? Come on, we're almost there. Number 3, true or false? C is greater than 0. What do we mean by C when I look at this equation up here? The y-intercept. Now, I want to caution you, most of us thought that because we were thinking back to a quadratic, right? But if the equation had been this, would C be my y-intercept in this case? No. Why not? What would it be? It has an x next to it. Remember, what does every y-intercept have in common? The x is 0, right? And if x is 0, this becomes 0. This becomes 0, right? If I substitute 0 in. What does this become? This becomes, and I'm left with In this case, my y-intercept would be 0, f. It's whatever the constant is. But we do or should notice that the c here is the constant, right? It is the y-intercept. So, is the y-intercept greater than 0? Is it positive? How do we know it is positive?
Because we look on the graph and look at the y-intercept that it's not lower than 0.
It's not below.
Nice, right? It's not below the 0. It's not below the x-axis. It is above the x-axis, right? This is good mathematical reasoning. Number 4, true or false, n must be 5.
Did I not say
True.
Huh?
Did I not say what do you want to do like right?
I was asking a question.
True,
I never said you were right or wrong. Why do you think it's true, Tyler?
because there's no double roots on the graph.
Okay, no double roots on the graph. Any other ideas?
And there's 4 terms.
There are 4 terms. So does n have to be 5?
Yeah.
Well,
Yeah, because there's only 4 terms.
Here's an equation. Could this have 5x intercepts? It could definitely have 5x intercepts, because it could have 7x intercepts or less. Could this have 4 extrema or 4 terms? Oh, by the way, why would this have 5x intercepts? Because 2 of the zeros would be imaginary. So I heard someone, I don't remember who had said it, but there's no double roots, is what you were saying, Tyler, right? And yeah, I definitely don't see any double roots, but could there be triple roots? Yeah. Could there be imaginary roots that we just don't see? Yeah. Could this power, could this degree have 4 extrema? Remember, what's the maximum number of extrema? No. Maximum number of extrema?
6.
6. But it could also have 4, oh,
I mean, not true.
4, 2, or 0, okay? So, does it have to be 5th degree? No. It has to be odd, and it has to be 5th degree or higher. That's something I want us to pay attention to. It has to be 5th degree or higher and odd. So that last one was definitely a trickier one to push your thinking, so don't sweat missing it. Learn from it. Just like I tell Alex all the time, it's okay if things are hard. Hard is what makes us better and stronger. So keep growing and learning. Okay? Okay. The rest of today is mostly going to be y'all tearing some pages out of the textbook before advisory starts, and we'll pick up with that stuff tomorrow. But here's something I want to quickly point out to you. So y'all got some Frere models with some check your understanding questions yesterday. Here's the first set of pages where I have given you some factored form polynomials, and it asks you to determine the standard form. Have we practiced going from factored form to standard form?
Yeah.
Was that on our last test? Would that be something that some of us need to practice? It also asks us to take this factored form and to graph what it would look like using that factored form. This is more intense than what I had y'all do in Unit 4, but it's to help us build our understanding. So you may want to do some of the Unit 4 stuff before you do this one. But you can do all of graphing from factored form and determining standard form. Here is a set of questions where I give you some characteristics of a function, right? And you sketch a graph that goes with this and create a possible polynomial equation. Okay? Notice it goes mild, medium, spicy again. Have we in class already looked at taking characteristics and creating a standard form equation from those characteristics? Maybe. So is this some check your understanding that some of us should probably do to check our understanding? Maybe. Okay. If I give you an equation, should you be able to identify some of the features from that equation, like the number of x-intercepts, the possible number of extrema, Should you be able to do that?
Yeah.
Yep. Notice the spicy then has you actually sketch a couple of graphs from each equation. The next set of Frere models just says identify the type of polynomials. Okay? When I say identify the type, I will point this out. What's the most basic polynomial that we have? What's the most basic polynomial we have?
Linear.
Linear. What's after linear? Quadratic, then cubic. Does anyone, and so don't forget, this means the degree is 1, this is a degree 2, this is a degree. Does anyone know what we call a degree 4? It is quartic, good job. If you look at your proficiency scales, that is a term there, right? So, identify it. Okay, so degree 5, anyone know? It's on the proficiency scales again. It is quintic. After quintic, you just say 6th degree or 7th degree, etc. So really, you can just say what degree it is. So on this one, I'm asking you to look at these graphs and try to figure out what degree that function is. Have we, or should we be able to look at a graph and play around and figure out what degree it might be? Yeah. We haven't talked about doing it with tables yet, we'll talk about it soon, but you do actually know how to do that as well. This set here, details of the equation based on the graph. Should we be able to maybe look at a graph and figure out a possible standard form equation? Sure. Yep. Extrema in building polynomials from zeros. I think this is the very last Frere model. That is the only Frere model, the only check your understandings, that you don't have the skills yet for. Everything else, based on this one lesson from Mathematic, you have developed the skills to be able to tackle it. I would start checking my understanding and practicing with these things. Mason's like, Mr. Kenny, what is practice? I'm so concerned about a grade, but I don't want to learn. I don't want to work hard for that grade. Mr. Kenny, the villainy expecting me to learn crap. You jerk. Now, the beautiful thing I will say is this. All of those things I just talked about, we're going to get more practice with. We're not done, but I have introduced all of those ideas. All of those things you can start to check your understanding, and the solutions are on the back. Okay? There's a few more things that we still have to cover, and so there are actually a couple of Frere models I think I'm going to create to add on to, because I don't think there's anything about intervals of increase or decrease, stuff like that we'll get into. Alright, so yeah, I'm just going to have y'all tear some pages out of the textbook. And so we're going to get more into these tomorrow. Let's just do this. Grab a textbook, tear out those pages from that textbook. We'll tear some more out later, but this is where we'll start tomorrow. Once you're done with that, I'll be nice to you and you can start advisory early. Yep, it has to be volume 1. They're the same, Mason. Just find those pages in that textbook. Find those pages in the textbook. By the way, hold up. Guys, that's 225 to 229. So everything from 225 to 229. And then everything from 235 to 237. Which is really not that much. Your evidence of understanding for sure. Hold on a second. Oh, I also need, sorry, I misdid that. 234 to 237 is what you need. And I'll have to fix that. I added one more page later. Thank you. 234 to 237 is what you need for that second set. This is just the stuff from that lesson 3 that we're going to use. And once you tear those pages out, it's advisory time. I know, Mr. Kenny giving you a whole extra 3 minutes? Wild. I don't even know who I am right now.
Are you like a clone?
Do what?
I think he says we can play.
I am the evil twin?
Yeah.
Yeah, what I have written up there.